Welcome to maths classes. In this video, we will see some Olympiad preparation problems. Okay, and the important formula we will learn Lagrange formula, which is very useful not only in Olympiad and also in your engineering entrance exams. Okay, this is part 13 of the video. Subscribe to my channel to see the other videos and learn math Olympiad preparation. Also, the old question papers of IOQM. Okay, let's get into the preparation problems. Okay, the least common multiple, that is LCM of A and B is 12 and LCM of B and C is 15. What is the least possible value of LCM of A and C? Okay, so LCM of A and B is 12, LCM of B and C is 15. This is what is given. Okay, so now if you see both of these, the common multiple is greatest common multiple or HCF. Okay, highest common factor is 3. Correct. So which means 3 should be the common number among all this, right? A and B and B and C. So let are 3 multiple in that case. Okay, let's try with the 3 first. Okay, so let B is equal to 3. Okay, if you take B is equal to 3, then LCM of A and 3 is 12, which means A is 4. Correct, right? And then LCM of C and 3 is 15, which means C should be 5. Okay, now all the sequence are matching. Now what we need is the least possible value of LCM of A and C, right? LCM of A and C is this is the least value, right? We have considered the minimum value and doing. Otherwise, we can take B is equal to multiple of 3 and try. Okay, so the least possible of LCM. LCM of A and C is 20, that is 4 and 5. A is 4, C is 5, so A and C LCM is 20. Okay, next. A computer is printing a list of 7th powers of all natural numbers. That is the sequence. Okay. Now, P is the number of terms between 5 to the power of 21 and 4 to the power of 28. Then what is the value of P minus 100? Okay. The problem is easy. Okay. Only thing is you may be just get confused by printing all these things. So just understand it carefully. Okay. The printer is printing something like 1 to the power of 7, 2 to the power of 7, 3 to the power of 7 and so on. Okay. Now we have to just write 5 to the power of 21 and 4 to the power of 28 in terms of some power of 7. Correct. So that is nothing but 5 to the power of 21 is 125 to the power of 7. 4 to the power of 28 is 256 to the power of 7. Correct. Now P is the number, okay, number of terms between this. Okay. So how many number of terms are between this 125 and 256? That is nothing but 256 minus 125 plus 1. Correct. That is 130. So P is 130. P minus 100 is 30. Okay. Hope you understand this. Next. Let P be the number of perfect squares. Those are divisors of the product 1 factorial, 2 factorial, 3 factorial up to 9 factorial. Then find P minus 600. Okay. What is P? P is number of perfect squares which can be formed from the divisors of this product. First thing you have to do is for finding perfect squares, you need to know the prime factors. Then we can easily tell how many perfect squares you can form. Correct. So first thing is the prime factors of 1 factorial, 2 factorial up to 9 factorial. This is how much? Okay. This is nothing but 2 to the power of 30 in terms of prime factorization. 2 to the power of 30 into 3 to the power of 13 into 5 to the power of 5 into 7 to the power of 3. Now out of this, how many perfect squares you can form? 2 to the power of 30 you can form. 3 to the power of 12 you can form. Okay. 2 to the power of 3 to the power of 13 you cannot form. 3 to the power of 12, 5 to the power of 4 and 7 square. These are the perfect square numbers. Correct. Right. Now these things I want to see what are the perfect squares which I can form using this. That is 4 to the power of 15, 9 to the power of 6. Correct. 3 square is 9. So 3 square if I take out, I am left with 9 to the power of 6, 25 square and 49. Now these are the my numbers with which I can form a perfect square. Other things I will just left out. Okay. I will just leave. So my new number should be formed from 4, 9, 25 and 49 with the powers given. Correct. So my x is 4 to the power of 15 into 9 to the power of 6 into 25 square into 49 to the power of 1. So how many factors this number has? That is the number of perfect squares I can form. Correct. So that is nothing but we know from the powers you can know 15 plus 1 into 6 plus 1 into 2 plus 1 into 1 plus 1. That is the power you take and add plus 1 and multiply. Okay. So 15 plus 1 into 6 plus 1 into 2 plus 1 and 1 plus 1 is nothing but 672. So I can form 672 perfect squares. Okay, with the given 1 factorial, 2 factorial up to 9 factorial. Okay, now, okay, the problem is actually not complete. The answer we should answer is 72 actually, not 672. P minus 600 is 672 minus 600, which is 72. That's the answer. Okay, next. Find the sum of all positive integers n for which n square minus 19n plus 99 is a perfect square. Okay, yeah, these are the very common problems which comes in the Olympiad. Okay, so there are one or two ways you can solve these problems actually. Okay, most of them will fall into one or two categories. This is one of the way you can solve. Most of the problems you can solve in this way. Okay, so let n square minus 19n plus 99 equal to x square, because it's a perfect square, it is given, so I am calling this as x square. Now if I take everything to one side, I am left with n square minus 19n plus 99 minus x square equal to 0. Now what is my n? N is a perfect square, we know. Correct? Sum of positive integers of n for which this is a perfect square. Correct? So now n is nothing but 19 plus or minus square root of 19 square minus 4 times 99 minus x square divided by 2. Now I know that my discriminant has to be perfect square to get a integer value of n. Correct? So my discriminant is nothing but 19 square minus 4 times 99 minus x square should be equal to some perfect square, that is q square I am calling it. Okay? Q square. Now 4x square minus 35 if I simplify equal to q square. Okay, or 4x square minus q square equal to 35. Now I can write this as 2x minus q into 2x plus q equal to 35, which is 35 has only how many factors are possible? 5 into 7 or 1 into 35. Correct? These are the two possibilities which are possible. Now we know that 2x minus q is always less than 2x plus q. So we have two cases only. First case, 2x plus q equal to 7, 2x minus q equal to 5. In this way, I will get x equal to 3 and q equal to 1. Okay, if x equal to 3, now substitute in the main equation. If x equal to 3, you substitute here. Okay, then you will get the value of n. Okay, so or directly in this expression. Okay, already we have solution, right? So 19 plus or minus 1 divided by 2, which is n equal to 9 or 10. These are the two solutions possible. Now case 2, you take case 2, 2x plus q equal to 35, 2x minus q equal to 1. So x equal to 9 and q equal to 17. Okay, x equal to 9 and q equal to 17. So since x equal to 9, you again substitute n is 1 or 18. Okay, now 4 values you have, you can cross check substituting. Okay, but the answer is sum of all positive integers, right? We need sum of all positive integers. So sum of it is 1 plus 9 plus 10 plus 18, which is 38. That's the answer. Next, if n factorial has exactly 20 zeros at the end, then find how many such n's are there. Okay, how many such n's are possible. Okay, so to solve this problem, we need to understand this Lagrange formula. Okay, so Lagrange is a mathematician, okay, who has derived a very simple formula to find out how many what is the highest power of a given prime number that divides n factorial. Okay, that means you are given n factorial and you are given a uh, prime number p. Then using his formula, okay, you can find out how many what is the power of this prime p which can divide n factorial, highest power. Okay, so that is e uh, p n factorial. Okay, here n factorial is the number given, p is prime given, so which is nothing but gif of or floor value of n by p to the power of 1 plus gif of n by p square plus gif of n by p cube continuously until how many numbers you will do? Until you get a this gif value as 0. Okay, n by p cube or whatever, n by p to the power of x, you will get 0. Until that time you will continue doing this. Now let's apply this formula in the given problem. Okay, so number of zeros in n factorial is nothing but number of 5 factors in n factorial. Okay, so which you understand carefully, it is not the number of 10 factorials or zeros, yeah, 10x basically. Okay, it is the number of 5s, means 5 factorial has a 5 into 2, which is 10, you will get 1 0. Correct? In 5 factorial you have 1 5. Now 6 factorial, 7 factorial, 8 and 9 all have 1 5, so only 10, only 1 0 you will get in the end. Now you go to 10 factorial, you have a 5 and you also have a 10. 10 has a 5 in it, right? Two 5s are there in the prime factorization. So you will get 2 zeros. Okay. Now again next is 15 factorial, you will get 3 zeros. Okay. So like this. So the number of zeros in n factorial is equal to the number of 5's in n factorial. That means 5 to the power of p, highest p you have to find out. That is the prime, right? Now you can apply this Lagrange formula to solve this one. Okay. So let's take first 25, n equal to 25. Why I am taking? I have n is equal to 5. If I take, I'll get only 1. Correct? Only 1, but I need to get 20 zeros. So let's find out. So n equal to 25, E5 25 factorial is nothing but 25 by 5 is 5 here. Okay, and 25 by 25 is 1 here. So that is 6 zeros in 25 factorial. Now let's take next one. N is 125. For n equal to 125, E5 125 factorial is nothing but 125 by 5, which is 25. 125 by 25, which is 5. 125 by 125, which is 1. That is total 31 zeros are there. So our answer is somewhere in between 25 factorial and 125 factorial. Correct? We need 20 zeros. So let's find out, and more towards 125. It is not towards 25 if you see. Correct? So you can either do binomial, you go midpoint and start checking which side you should go. Okay? Or approximately, if I see around 84, n equal to 84. Okay? That is 84 factorial has 84 by 5, which is 16. 84 by 25, which is 3, and 84 by this one is 0. So total 16 plus 3, 19 zeros are possible with 84 factorial. Next. Okay. N equal to 85 will get 20 zeros. Okay. So this is the beginning of 20 zeros in n factorial. 85 factorial will have 20 zeros. Similarly, you can check 86 also will have 20. Okay. 17 plus 3 only. Okay, and 87, 88, 89 also will get 20 zeros, and n equal to 90, 90 factorial will have 90 by, first thing is 90 by 5, which is 18. Okay, then 90 by 25, which is 3. So you will have 21 zeros. So this is not qualified. Which are the qualified ones? 85 to 89, that is 85, 86, 87, 88 and 89. That is total 5 such numbers are possible which will have 20 zeros in the end for that factorial. Okay, hope you understand this Lagrange formula. This is very important, and this problem has straightforward as come in JEE also. Okay, very simple, not even as complex as this problem. It is straightforward given how many number of what is the highest power of 7 in a given some 20 factorial, like that. Okay, so understand this one. This is very useful. Next. Number of positive integers less than or equal to 3600 that are co-prime to 3600 is alpha. Then what is the value of GIF of alpha minus 100? Okay, so this one we learnt already, this problem, Euler-Stotiant function. We have to apply same thing here. Okay, you can refer to my previous video in the same playlist. Okay, that has the Euler-Stotiant function explanation. Okay. Okay, you need to use Euler-Stotiant function. Okay, you can check my same playlist. That is, formula is simple. Formula is phi of n. Okay, number of co-primes is equal to n into, okay, 1 minus 1 by p into 1 minus 1 by q into 1 minus 1 by r continuously. What is PQR? PQR are the prime factors of n. Okay, these are the prime factors of, if you take the prime factorization of n, if it is p to the power of a, q to the power of b plus r to the power of c, these are the PQRs. Okay. So let's see. Now your n is 3600, we know. If I do prime factorization, it is 2 to the power of 4 into 3 square into 5 square. Okay. So phi of 3600, which is Euler-Stotiant function, is nothing but 3600 into 1 minus 1 by 2. 2 is one prime factor here, into 1 minus 1 by 3 into 1 minus 1 by 5. Okay. If I simplify, I'll get 960. This is my alpha. Okay. So 960 numbers are co-primes with 3600. That means now all I need is a GIF function, right? Alpha by 960 by 100, which is 9.6. 9.56, 9.6 greatest integer function is 9. That's the answer. Okay. Next. In how many ways 10 different balls can be distributed among 2 boys, one receiving 2 and other receiving 8? So basically you have to divide the balls into 2 balls and 8 balls, correct? So that can be done in 10C2 ways or 10C8, both are same basically. So that looks as simple as 10C2 or 10C8, which is 45, right? But this is not correct answer. What you are forgetting is you can actually choose which boy to give. correct? There are two boys. You can give two balls to boy 1 or two balls to boy 2. Okay, that is also two ways, right? So include that. Okay, number of ways to select a boy, which is two number of ways. So total number of distributions possible are 2 into 45, which is 90. This is the answer. Okay, next. If x square into y cube equal to 6, then least value of 3x plus 4y is equal to how much? Where x comma y are real numbers. Okay, so this problem can be solved using two methods. One is the number theory, where you use the arithmetic mean is greater than or equal to geometric mean formula. Second one is calculus. You can use substitute x value x equal to 6 by basically x square equal to 6 by y cube. So you can make x in terms of y and change the 3x plus 4y into single variable equation and then apply differentiation to find the maximum and minimum value. Okay, so in this one, basically in Olympiad, we don't want to use calculus as much as possible. Okay, so I'll use the arithmetic mean greater than or equal to geometric mean method. Okay, so let's solve using AMGM rule. Okay, so 3x plus 4y I can write in 3x by 2 plus 3x by 2 plus 4x by 3 plus 4x by 3 plus 4x by 3. Why did I choose by 2 for 3x and by 3 for 4y? Because I have a value for x square into y cube. How do I get x square? If I multiply these 5 terms, I get a x square term, I get a y cube term. Okay, so x has to be divided by 2, correct, and summed up. X term, y term should be divided by 3 and summed up. That's why I choose this way. Okay, now I know this is my equation 3x plus 4y. Now what is my arithmetic mean of this one? Arithmetic mean of this one is whole expression sum of whole thing divided by 1 by 5, because I have 5 terms here, which is equal to 1 by 5 into 3x plus 4y. Okay, now what is the geometric mean of this one? 5 terms, so fifth root of multiply the terms 3x by 2, 3x by 2, then 4x by 4y by 3 whole cube, which is 9 by 4 x square into 64 by 27 y cube whole to the power of 1 by 5, which is nothing but, if I simplify, 16 by 3 x square y cube whole to the power of 1 by 5. Okay, now I know that AM is greater than or equal to GM, correct? Which means 1 by 5 3x plus 4y is greater than or equal to this geometric mean. Okay, now I know that x square y cube is equal to 6. So if I substitute 6, this value is nothing but 2. Okay, so 1 by 5 into 3x plus 4y is greater than or equal to 2, which means 3x plus 4y is greater than or equal to 10. Then what is the least value of 3x plus 4y? Which is 10. Okay, so this is how you solve using arithmetic mean greater and geometric mean rule. Okay, AMGM rule. Okay, next. Find the units digit of 2 plus 1 into 2 square plus 1 into 2 to the power of 2 square plus 1 into up to 2 to the power of 2 to the power of 10 plus 1 plus 1. Okay, so you look at these numbers, the 2 is going actually power is increasing. Okay, first one is 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 2 up to 2 to the power of 10, correct? So there are total 11 a product of 11 terms here plus 1. Okay, so if I multiply this expression with the 2 minus 1, what happens? This is 2 square minus 1. Okay, 2 square minus 1 into 2 square plus 1, again it will go into, right? Everything can be uh, uh, everything can be removed and only one term will remain. Okay, let's see that way. Okay, this is what it is given. So I am multiplying and dividing with 2 minus 1. Okay, so 1 by 2 minus 1 is nothing but 1 by 1. So I can ignore now, into 2 minus 1, right? So 2 minus 1 into 2 plus 1 is nothing but 2 square minus 1 into 2 square plus 1 into rest of the things. So that will also go. And finally, this will become 2 to the power of 2 to the power of 2 square minus 1, which will again multiply with this one. It will become 2 to the power of 2 to the power of 3 minus 1 and so on. So finally, I will be left with 2 to the power of 2 to the power of 11 minus 1 plus 1, which is already there. So plus 1, which is nothing but 2 to the power of 2 to the power of 11. That is 2 to the power of 2048. 2 to the power of 10 is 1024. 2 to the power of 11 is 2048. Okay, so 2 to the power of 2048. Now all I need is simple, 2 to the power of 2048 congruent to x modulo 10. This is what the unit digit, right? You will get unit digit this way. Okay, we have to find x. Okay, now 2 to the power of x is cyclical. Okay, you just need to find the remainders. All the any number remainder is cyclical. Maximum is 4. Okay, okay, cyclicity of number is 4 maximum. Some of them have less than 4. Okay, let's find out 2 to the power of. Okay, 2 to the power of x is 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 4, 5. If I write like this, the units digit is 2, 4, 8, 6 and 2 cyclical, right? So 2, 4, 8, 6 and then it becomes cyclical. 2 to the power of 4 basically. Cyclicity is 4. So 2 to the power of 1 remainder with when you divide with 10 is 2. 2 to 2 square is 4. 2 cube is 8. 2 to the power of 4 is 6. 2 to the power of 5 is 32. 32 means 2. Correct? So this is 2 to the power of 2048 is congruent to 2 to the power of 4 because cyclicity is 4, so I can divide with 4. Right? This is divisible by 4. So I just need to find out 2 to the power of 4 mod 10, which is nothing but 6. 2 to the power of 4. 2 to the power of 1, 2, 3, 4. Right? 4 is 6. 6 mod 10, which is 6. So the units digit is 6. That's the answer. Okay. Next. Yeah. Thank you. These are all the collection of problems for Olympiad preparation. Okay, especially those two Lagrange's formula and then Euler's totient function, those two practice more. This is useful not only for your Olympiad but also for your engineering entrance exams. Keep doing maths. I'll make more videos on Olympiad also. Okay, keep watching my channel. Thank you.